Good afternoon, Algebra 2. Today is the April 20th. Um, what I'm going to tell you today is the geometric sequence explicit formula. Now, last week we have talked about sequences, and we have also been talking about how we can find out explicit formulas to model the sequences and make sure that once I plug in the first term and the common difference or the nth term, that I'll be able to solve for whatever that the question is asking you to solve for. Now, above that, which is your arithmetic sequence, the geometric sequence is the other type of the list of numbers that we've been studying. And this is the second one, this is the last one. And the formula for geometry sequence is going to be this. So for right now, I would like every single one of you guys to take out your notes and write down this formula that says that a sub n equals to the first term times the common ratio r to the power of n minus 1. Now, I'm going to show you guys a series of how that formula came to being. We're going to try some of these questions, and then today what I'm only going to ask you is to formulate explicit formula for geometry sequences only, and that's going to be it for today. Tomorrow and on Thursday, when you guys have a weekly assessment once again, you will be asked to solve questions like this, very much similar to your quiz from last Thursday. Now, the major difference between a geometric sequence and an arithmetic sequence, as I hope you remember, is that geometric was multiplication slash division. Arithmetic was plus or a minus sign. This was a lot easier and we just got it out of the way last time, but today we're going to be talking about geometry sequences. Let's consider this possibility in the table. 2, 4, 8. Now you know that the common ratio here would be times 2. So the ratio here, the common ratio we like to call it, is 2. So in this table we have these term numbers called n. That's your nth number in the sequence. The very first number is 2, the second number is 4, and the third number is 8 as listed. So what do we multiply to each of the terms here? Well, that's 2 times 1, 2 times 2, 2 times, well actually that's 2 times 4. So it's going to be a little bit challenging to do. But at the same time, what's going to happen is this is the same thing as saying 2 times 2 to the 0th power, or just let's say just 1 times 2. This here is the same number from the previous number, and you multiply by 2 one more. This here is this number, 1 times 2 times 2, or 4, times another 2, and then it's times another 2, times another 2, times another 2, and this list will go on and on and on. So what really happens is that you take the very first term, and then you want to multiply by the common ratio, which is 2. But how many times are you multiplying by? You're multiplying 2 twice, okay? Well, actually, once, because you're multiplying to the original term. The original term is 1 times 2, that's a sub 1, right? So that's your a sub 1. So let me use different color to indicate that. So a sub 1 is 2. So this stays the same. A sub 1, 1 times 2, 1 times 2, and so forth. But how many times are you multiplying 2 by? Well, in this particular case, you're multiplying 2 once, you're multiplying 2 twice, and then most likely for this one, you'll be multiplying by 3 times. But here, I want you to take a look at this number, where I'm multiplying just once, to this number. This is 2. You're multiplying twice with this number, 3. You're multiplying thrice, or 3 times. This is 4. So what's happening? It's simply the n minus the 1 value gives you that. So 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. So we are still going to be using the n minus 1, very similar to the one we talked about in arithmetic sequence, which is d times n minus 1. That is what we're going to be incorporating to the power now, because that's how many times I am multiplying by. It's raising to the power. Raising it to that power allows us to calculate that many times multiplication. So 2 times 2 times 2, I'm multiplying 2 3 times, and so forth and so forth and so forth. Okay. All right. So let's try actual problems here, and then find the explicit formula, and then do and the three terms in the sequence after the last one's given. That I'm not going to ask you to do. I'm simply going to ask you to find out. Let's say find the explicit formula and tell me the ace of, I don't know, 10. Of course, you can take your time and then constantly multiply by the common ratio until you reach the 10th digit or 10th number. But if I were to ask you for the 100th term, then you probably don't want to do that by hand, one at a time, because that's going to take forever to do. Remember, guys, the formula is always this. A sub n equals a sub 1 times r to the n minus 1. So a sub n equals a sub 1 times r to the n minus 1. Here, my first term is negative 2. My common ratio here, it seems like you're multiplying each term by positive 2, because positive 2 times negative 2 gives you negative 4. Negative 4 times negative 4 times positive 2 is negative 8, and so forth and so forth and so forth. So that's 2. So now what I'm going to do is I'm going to incorporate that here and say my explicit formula, I hope you got this from your quiz, is that a sub n is equal to negative 2 times 2, common ratio, to the power of n minus 1. Okay, that's just the explicit formula. Now to do the final question where it says that I want to find out what a sub 10 is, you have to make sure that the n value is 10. So negative 2, 2 to the 10 minus 1, negative 2, 2 to the 9th power. Well, if you type in 2 to the 9th power, it's going to give you a crazy number. So if you take out your calculator, 2 to the 9th power, it's 512 times negative 2. So my final answer should be negative 1024 if I were ever asked that question. Pause the video right now for me and then try number 10 on your own, and then verify the answer with me after you're done. Okay, so first of all, we gotta identify two things. Number one, a sub 1. Number two, common ratio. A sub 1 is negative 1. Common ratio is times positive 5, because the negative sign stays consistent. So that means you're only multiplying by positive numbers each time. So my explicit formula would be negative 1 times 5 to the n minus 1. Done. A sub 10 means negative 1, 5 to the 10 minus 1. Just plug in n as 10. That's 5 to the 9th power times negative 1. So my answer will be a little bit crazy. It will be 1 million, negative 1,953,125. Okay, so that will be the answer. All right, so let's try some of the more questions here. Writing the equation for the nth term, we have done this before. Now, they're going to give it to you in different contexts. So let's say if I give you a list of numbers, or if I give you strictly just the fourth term in the sequence and then the common ratio. So how would I be able to do those questions and things like that? Once that's done, I would like you to try these two problems for homework for today, and that's going to be it. And then for the independent practice, I'm going to give you maybe 2 of these questions to do also, and I'm going to check it for by the end of today. Okay, so I'm going to go over these 2 problems. Write an equation for the nth term for each geometry sequence. Now, a is pretty simple. We have the first term, so a sub 1 is 0.5, and common ratio is, well, it's kind of not obvious in this case, but you can just simply take a look at 2 and 8 and you can kind of figure that out, right? Or if you're ever in doubt, just take the 2 subsequent numbers and take the right hand side divided by the left hand side. So 8 divided by 2 is 4. So my explicit formula will be a sub n, 0.5, 4 to the n minus 1. That's it. Now the problem with this one is that I have common ratio 6, but the problem is I have no idea what a sub 1 is. So I have to actually go out of my way and solve for it. So if I know that there are 1, 2, 3, 4 term, which is the 5. This is your a sub 4. I actually need to retract back and then actually solve for the a sub 1, right? Or you can simply utilize the explicit formula. It doesn't matter. So you can keep on going opposite direction, which means you're dividing by 6 each time. Or I could do a sub 4, which is 5, is equal to a sub 1 times the common ratio to the power of 4 minus 1. Because that's the explicit formula when the n value is given to me. So 5 is equal to a sub 1, 6 to the power of 3. Well, 6 to the power of 3 is 216 times a sub 1. Divide both sides by 216, and there we go. I have a sub 1. Now, I know it's not a really pretty fraction, but that's just the way it's going to be. So my final answer here would be a sub n, explicit formula, is 5 over 216 times 6 to the n minus 1. That would be my final answer. Take a look at these two questions as an example and try these two questions. If you would like to do them right now, you can. Of course, I'll give you the same questions on the homework page as well. But once that's done, I'm going to give you these two questions to do. Actually, these are arithmetic sequences, so I'm not going to give you those. I'm going to give you these two. We're talking about geometric. Actually, well, I'll be mixing these two, so I'm gonna give you these two. So just to make sure that you're able to do arithmetic sequence and not forget about that, I'm gonna forget about the even numbers. I'm just gonna give you odd problems to do. Okay, so total of 4 questions for homework today. Please stay safe out there, and I'll talk to you guys tomorrow. Thank you, and have a good day.